Hello, I welcome you all for my mathematics class. This is the problem that I am going to do today, and you see that here this is something different. I have taught in my last class that what is a discrete random variable. See, I write as P of x is equal to x. This is the probability mass function. This is PMF, and this is probability density function. So you see that this is how we differentiate the probability mass function for discrete random variable. Here x is a discrete random variable which takes finite values or countably infinite number of values, and this is your f of x, which is nothing but, here if you want I can write here like this. So this is x is a random variable and the variable is x. This is a probability density function, and actually we define this as x minus dx by 2 less than or equal to f of x this is how we define the probability density function, because this function will be defined over an interval. As I had already mentioned, that if you want to study about persons like Abdul Kalam, you see that he lived for some 82 or 83 years. So let us suppose that we became interested in learning, in knowing about Abdul Kalam from his college days. Then you see that from his 20th year till his death, you see that the period runs. So it is going to be a continuous, we are going to continuously watch the life of Abdul Kalam. So you see that we can study. So that whatever happens, they are nothing but random variables. So you see that random things happen, and we can just study about all those things there. So it is just like that. So you see that means what? A continuous random variable is a variable. It is a function from the sample space to set of all real numbers which are not finite, I should say here, which runs over an interval. Can you understand? That means you see that here between x minus dx by 2 and x plus dx by 2, a small interval we have taken. So like that we can have any interval of size, and f of x will be taking values on that interval. So such a function will be called as a probability density function. These two are the same, with the difference that this is taking finite values or countably countably infinite number of values, and this function runs over, takes values between two limits or in an interval. So that is that. And here again this is f of x is less than or equal to 1, and that here f of x is always greater than or equal to 0. Here you see that f of x is always greater than or equal to 0, and minus infinity to plus infinity, f of x dx is equal to 1. And we can also define something. See, here we can see cumulative distribution function is defined as we have done. So this is nothing but minus infinity to x f of x dx. And that here you see that here we can take that is so this is nothing but and we can have it like this. See, p of fx of we can write fx of b minus fx of a is equal to, it is a to b of f of x dx, and f of x is equal to d by dx of f of x. So some of the important definitions and properties I write here. Fx of x, which is nothing but the cumulative distribution function, which is given by minus infinity to x f of x dx, and f of x, fx of b minus fx of a is equal to a to b of f of x dx, and this probability density function is nothing but the derivative of f of x with respect to x. So these are the important things that you must know before doing this problem. In fact, this is a discrete random variable. Here this is a continuous random variable. I have taught you about the discrete random variable, and problems have been done in discrete random variable. I am yet to do problems in continuous random variable, and this is a continuous random variable problem, so which will be discussed today. Okay, now let me start doing this. So you see that what is it given here? So it is given that the diameter of an electric cable, see there is a cable, and the diameter means, you know, twice the radius is diameter, and the diameter is given to be a random variable, that is between in that electric cable, which is of length 0 to 1. You see that the diameter is a random variable, and that this random variable is x is assumed to be continuous random variable. That means what? That random variable will be taking, see, like this, that is 0 to 1. So this is a cable, and you see that this cable, we are measuring the diameter of the cable at every point. The points are continuous. The points are continuous between 0 and 1. And x is refers to, x is a random variable, and x is a point. It is a sample point on this, and it runs over 0 to 1 continuously, and that it is given that f of x is 6x into 1. So you see that wherever this probability density function on x, its value is equal to 6x into 1 minus x. Now you are asked to check whether the above is a PDF. I told you that if f of x is if you call this f of x a PDF, what is the meaning of that? A probability density function. Then you see that this f of x must be greater than or equal to 0. It cannot be negative. You see that the value of this runs from 0 to 1. At the least, if it is 0, so if you put 0, f of x is equal to 0. It does not become negative. If you put 1, it goes up to 1. If you put 1 also, it becomes 0. In between, it takes all values. They are all positive. Can you understand? So you see that this f of x, the first point that you must know is, I will do the first one. See, clearly f of x is greater than or equal to 0 for all x lying between 0 and 1. So between 0 and 1, it takes the values 0 and also 1. So for all values of x 0 to 1, this f of x is greater than. So that first point is over. And second, check whether it is going from 0 to 1. So 0 to 1, 6x into 1 minus x dx is equal to 1. Check whether this is true. Now what is your LHS? Take this 6 outside. So it is 0 to 1. You can do it in any way you want. X squared. So 6 into x squared by 2 minus x cubed by 3, 0 to 1. So 6 into half minus, if you put x is equal to 0, it is 0. So this is 3 minus 2 divided by 6 into 6, that is equal to 1. So you see that, now the probability, this is your probability density function. This is your f of x, this is your probability density function. This is your f of x. So you see that we are able to prove that the summation of f of x between 0 to 1 over this interval 0 to 1 is equal to 1, and therefore definitely f of x is a probability density function. So you see that this is over. So we have checked that this is a probability density function for the simple reason f of x is greater than or equal to 0 for all values lying between 0 to 1, and that we have verified that the value of this is also equal to 1. Hence this f of x is a probability density function. So that is over. Now the second one, what is the second one that is asked for you? So let us take the second one. So what is the second one? Determine B such that this statement is true. What is that? Determine B so that this statement is true. Now you are given P of x less than B is equal to P of x greater than B. You know, what is the meaning of this? So this means that this implies, so you can write in any way you want, this is nothing but, as per definition, this is going from less than B means 0 to B, because I have told you that if it is this f of x, if it is a probability density function, your f xb will be equal to, it is minus infinity to b f of x dx, and p of x greater than b means it is b to infinity f of x dx. And as I told you, if you have it like this, p of a less than x less than b, you put it like this, is equal to a to b of f of x dx. So these things you can, these are the understanding that you must have with regard to what is that, the probability density function. So you see that if x is less than b, then it means that what? Minus infinity to b f of x dx. X dx. X greater than b is b to infinity of f of x dx. Lying between a and b is what? A to b f of x dx. So this is what we now applying that idea. You see that this f of x is defined in this interval 0 to 1. So it is f of x is defined only in this 0 to 1. So it b is any point lying between what? 0 to 1. B is any point lying between 0 to 1. So you see that 0 to b f of x dx is equal to, this is nothing but what? It is b to So it is b to 1. So from b it must go up to what? From b to 1. So this is f of x dx. So this implies, what is that you get here? It is 0 to b. It is your 6 into x into 1 minus x dx is equal to, you have this as, it is 6 into b to 1 of x into 1 minus x dx. Cancel off this x and 6. So this is nothing but your x squared by 2 minus x squared by 3, 0 to b is equal to, you have this x squared by 2, x cubed by 3, it is b to 1. This implies only b has volume. B squared by 2 minus b cubed by 3. If you apply this, is 1 by 2 minus 1 by 3. It is minus, if you apply the limit, it is b squared by 2 minus b cubed by 3. So you see that, what is that you get here? So I'll write here, bring this to the left hand side, minus will become like this, 2 into b squared by 2. So that is 3 minus 2 is 1 by 6. So this implies b squared, what is that? 3b squared minus 2b cubed, 6. So this and this will go off, giving you 3. You can write this as 3b squared minus 2b cubed is equal to half. 6, I can multiply and write 6 b squared minus 4 cubed is 1. This implies 4b cubed minus 6b squared. It will be minus, it will be plus 1 is equal to 0. So this is very simple. You can approach this problem in another way also. So you see that I am getting in this way 6b squared minus 4b cubed. These are all very ordinary integration and ordinary substitution and ordinary algebraic simplification, nothing more. So you see that I am getting in this way. That means this b is a point lying between what? So you're calculating the probability in some point lying between 0 and 1, and that is b is somewhere. Now the question is, what is that b for which this can happen? What is that? What is that value of b for which this can happen? Indirectly what I can say is that, what is the value of b for which this equation is satisfied? Can you understand? So I have done all this. See whether these two are equal, or for what value of b this equation is satisfied, both are equivalent. Can you understand? So the question is, for what value of b this is true. So I know what is the definition of these two. So I do everything. I do that integration, I do the simplification, substitution, simplification, and able to bring it to this algebraic form, algebraic equation. Now my question is, what is the value of b for which this equation is satisfied? That is as good as asking, what is the value for which this b is, for this one is true. See, for which this 1 is true. Now what is that? You take, say we need, because 0 and it lies between 0 and 1. See, obviously you see that you take b is equal to half. For no other value it will be 0. There can be only one value for which this can be 0. So you see that this is b is equal to half, means what is that? 4 into, it is 1 by 8 minus 6 into 1 by 4 plus 1. What is it equal to? This is half minus, this is 3 by 2, 1 and a half plus 1. See, this is 1 and a half, this is minus 3 by, this is also 1 and a half. This is half plus 1 is 3 by 2 plus 3 by 2 minus 3 by 2, this is equal to 0. So what is your value? So b is equal to half, for which this can be true. Are you able to understand? So this is one way. Another way is you can say that it is 1 minus p of x less than or equal to b. Whether it is less than or equal to b, it doesn't make much of a difference. We can bring it to this side and do the problem, then also you will get the answer. So you see that I am able to get the value of this. So this is b is equal to half. So this is over. This is over and this is over. Now let us start. So this is the second question that is over. Now let us do what is our cumulative distribution function, or the distribution function, how to find the distribution function. See, what is the meaning of distribution function? The distribution function is like this. Distribution function, cumulative distribution function fx of x, this is equal to p of x less than or equal to b. So for this it is minus infinity to b f of x dx for continuous random variable. So this is how you find the cumulative distribution function for this one. Now you take this, what is your, this one, see, f of x is equal to 6x into 1 minus x, 0 less than or equal to x less than or equal to 1. Now what is your fx? Fx of x, it is equal to 0 to, so this is up to 0 to x. 0 to x, see, 0 to x, you can have it like this. It is f of x. What is your f of x? You can write this as now. See, f of say x, say I 1 minus y into dy. Because since I have to using this x variable here, I am just, because whether you put x or y, it is not going to matter at all. After all, they are going to be variables. So instead, because I am going to substitute x, I am changing this x variable here to y variable. So this is equal to what? So this is equal to y squared by 2, y cubed by 3. It is x and 0. 0, it will be 0. Try to understand, for 0, whole thing will become 0. So it is 6 into x squared by 2 minus x cubed by 3. So this is, so you say that this is, see, for what happens is that, so this is your cumulative distribution function. See here, this x is defined from 0 to 1 only. So for all values of, so you can discuss about three parts. One is, what will be happen to this cumulative distribution function for values x less than 0, x lying between 0 to 1, and for values x greater than 1. So three things we have to discuss. One is value of this distribution function for values less than 0, for values lying between 0 and 1, and for values greater than 1. So what is that you will do? So this fx of x will be equal to, see, it is 0 because it is not defined below 0. So it is 0 for all values x less than 0. So for x less than 0, the function is not at all defined, and for 0 to 1, that is correct, because it is 6 into x squared by 2 x cubed by 3, 0 less than or equal to x less than or equal to 1, and is equal to, so after this, after 1, see what is the maximum value of probability? It can be equal to 1. So you see that we have proved that up to the probability of the density function, I mean over that interval 0 to 1, has been proved to be 1. It can be only 1. After then, it will remain as 1 only throughout. Whatever changes that are taking place on this, it is going to be 1 only. So you see that for this is equal to 1 for all values greater than 1. Are you able to understand? So you see that for all of us rest of the values, you see that this is going to, so this is called your cumulative distribution function. And here I want to make a small mention of a very important aspect. Here you see that this probability, cumulative probability density function is 0 for x less than 0. So don't worry about this. For x greater than 1, it is equal to 1. So now my question is, you take this, if they give you, let us suppose that you are given only this. Let us suppose that you are having only this is given to you. That is, this is given to you. If you are asked to find the probability density function, what is that? Probability density function, because I can ask in that way also, because here you see that here you are given probability density function and they have asked you to get the cumulative distribution function. Now let me tell you that the cumulative distribution function is given to you like this. What is the probability density function? What is that we do? Say I'll write here, if this is my own question I am giving you here. So it is like this. If this is given, find PDF. Can you understand what I am writing? This is my question that I am giving you here. If 0 f of x, this is 0 for x less than 0, it is equal to this for this, and it is equal to 0 for x, then find the PDF. See, you are going to differentiate. What is that PDF? If f of x is given, then the PDF, f of x is equal to d by dx of f of x. d by dx of f of x. Now here f of x is equal to d by dx of f of x. See, d by d of 0 is 0, 1 is 0. We will find only the difference here. See, probability density function for this is 0. I will write that also, don't worry. So this is equal to d by dx of 6 into x squared by 2 minus x cubed by 3. So take that constant outside. D by dx of this is 2x by 2 minus 3x cubed by 3. This and this will go up. So 6. So you see that. So how will you write this? So your f of x is equal to 0 for x less than 0, 6 into 1 minus x, 0 less than or equal to this, and is equal to, and what is the value of this? Value of this is, see here in this interval it is also no, differentiation of this is 0 in x greater than 1. So you see that means for x less than 0 it is 0. That means for, see here you can write here if this is correct. See, for this is f of x is PDF is not existing for below 0 and for more than 1 it is not existing. So this is as simple as, so this implies f of x is equal to 6 into 1 minus x, 0 less than x less than 1. So this is enough. So this is this has no meaning, because for x greater than 1 PDF is 0, for x less than 0 PDF 0, only for 0 to 1 the PDF exists, therefore you get this. So this is how we do this part, that is distribution of this. So that is over. And incidentally, you see that I have taught you, if f of x is given, cumulative distribution function is given, how to find the probability density function for that, and I have thoroughly explained how you should get this. Follow this, you will get the answer for any problem. So understanding is very, very important. When you understand, solving any problem is not difficult provided you practice. So that is the only advice I can give. Now let me go to the last one. So you see that this is over. So this is over. Now let me come to this, the fourth one. See, what is P of x less than or equal to half slash see, you know that x is a random variable here, x is a random variable moving over this 0 to 1, and you are asked, can you see this? This is, if you take this as your A and this as your B, this is nothing but your conditional probability. We know that P of A slash B is equal to P of A intersection B divided by P of B. Provided this P of B is not equal to 0, this is conditional probability or multiplication theorem. This is happening. Now, here P of x less than or equal to half is equal to, so here let me do like this. See, it is 0, it is half is here, 0.5. 1 by 3 is 0.3 somewhere here, and this is 0.6. So you see that it is between, see, this and this. So you see that it is x is less than or equal to half, means between 0 and 0.5, and this 1 by 3 and 2 by 3, 1 by 3 is 0.3 and yes, and this 2 by 3 is 0.6. Now what is the common portion that is between this random variable? Here you see that this is the one and this one. So you see that 0.3 to 0.5. So you see that this one, this is nothing but, it is nothing but your probability of 1 by 3, see, 1 by 3 less than x less than 12. So this is divided by 1 by 3 less than x less than 2 by 3. Can you understand what I am doing? See, here instead of 3 I wrote it as 2. That is difficult. So you see that you plot these points here, it is up to 0.5 and this is 0.3 to 0.6. What is this? Is 0.5 and this is 0.3 to 0.6. what is common that is between these two? It is 0.3 to 0.5. So this conjunction of these two will become what? These two are set. This is a set, this is a set. Conjunction, the intersection of these two sets is nothing but 0.3 to 0.5. That is probability of 1 by 3 to 1 by 3 to 1 by 2 divided by this. So you see that it is, now you have to evaluate this 2. Now you see that you are going to evaluate this integral. Okay, now if you evaluate this, then this is the value of this. Now let me write here. So this is equal to, I will write here. So this one I will straight away write. So this is nothing but, it is 1 by 3 to 1 by 2. 6x into 1 minus x dx divided by, it is integral of 1 by 3 to 2 by 3, 6x into 1 minus x dx. That's all. If you are going to solve this, then your problem is over. Therefore, I will write here. Therefore, you call this as 2. Therefore, 2 is, see, what is on this? So this 6 and 6 will go off. So this is nothing but, it is, if you integrate x squared by 2, x cubed by 3, and it is running from 1 by 3 to 1 by 2, and this is also x squared by 2 minus x cubed by 3, and it is running from 1 by 3 to 2 by 3. 1 by 3 to 2 by 3. So this is equal to what? That is what you get here. It is 1 by 4 means 1 by 8. Minus this is 1 by 4, 1 by 8. This is 1 by 8 means minus 1 by 24. Minus, this is your numerator. Your numerator is this. If you put it as half, if you put it as half, 1 by 8, if you put it half, 1 by 3, then now you put, substitute this 1 by 3, 1 by 9 minus 1 by 18, minus, if you put, it is 27, 81, 1 by 81. So I'll write it here. So you see that what is that you will get here? So you will get this to be what? 3. 3 minus 1 is 2. So 1 by 12. Multiply this by 3 and this by 3. 24. 3 minus 1 is 2. 2 by 24, 1 by 12. Minus, this is 81. So you see that what is, if you simplify, how much will you get here? So you take this 1 by out 9. So 1 by 2 minus 1 by 9. So this will be 18. 9 minus 2 is 7. 7 by 18 into 1 by 9. 9 minus 2 is 7. This is 18. So you see that this is equal to minus 7 divided by 18 into 9. Now what is your denominator? So you see that what is your denominator here? It is again, if you substitute this 2 by 3, it is 4 divided by 9 means 18, minus, if you substitute, this is 8 divided by, this is 81, minus, if you substitute this 1 by 3, it is 1 by 18 minus 1 by 81. So this is what you get. So you see that if you want, this is 4 by 80 minus 8 by 81 minus 1 by 81, that's 10. So this one means 4 minus 1 is 3, minus, 8 by 81, 7 by 81. So this is what we get here. So I will write here to do the simplification. What is that you get? 1 by 6 into 13 by 54. Take this to the top, 18 divided by 13. 13 goes off. This goes off 3 times. So this is equal to half. So you see that what is the answer that you get for this? So this is equal to, so I have not done anything. I am only thing where you should concentrate is how do you get this value. So this finding this value is very, very important. See, here I have got here 1 by 3. This is very, very important. This is nothing but this your integral. I have shown you this. After then simplify all these things, giving the numbers, you get the value to be, this is your half. So you see that I am able to get the value of this on this. This is your conditional probability, and this is what I have done. So in today's class I have taught you about what is a probability density function, what is a cumulative cumulative distribution function, and what are the properties of a probability density function, and when given probability density function, how to get the cumulative distribution function. And incidentally I have also taught you when distribution function is given, how to get your probability density function. So all these things have been taught. We will see more problems in the coming days. Thank you.